Hello everyone. Hope you're having an amazing day as you're sitting down to listen to this lecture and learn about group research designs. Now this is going to be chock full of quite a bit of details, and you may have to go back and re-listen to it, reread the book. This is actually the bulk of research. This is the methodologies that we primarily use when we're studying human behavior. So understanding the different levels of these group research designs is very important as you move forward and begin to design a project. Single system design, which was last week, and then the group research designs, which is this week, are the ones that from social work and behavioral sciences we mostly engage in. So let's just get started and delve right into this and see what we can learn. First of all, some of the things that we've already gone over play into our choices for group level designs and the methodology that we choose to gather our data and answer our research question. And that's the first thing, is in determining which type of design we're going to use, one of the things that we have to consider is what is our research question and how best can it be answered. If you go back to that model that I provided you at the very beginning of the semester, it gets to that point where it says, how can I best answer my research question or test my hypothesis? And this is where we get into choosing the research design that we're going to do. So we have to know what our research question really is before we can choose the design of how we're going to answer that. And then we have to consider how much knowledge about the problem area is available. If it's very early in the knowledge level continuum in terms of the topic that you're going to be looking at, you're going to engage in an exploratory level research. You couldn't go all the way to the explanatory level unless you have knowledge has been empirically established and published in terms of that research question. So you will need to engage in that review of the literature, which then tells us the level of knowledge about the problem area or the intervention, whatever it is that's available, because these two factors really inform the group level design that we choose to answer that research question and to gather our data and to be able to make sense out of our data. Okay, so let's just briefly review the knowledge levels of continuum that we've kind of gone over earlier in the semester. And first of all, we have the exploratory level. We looked at creating questions for exploratory research, but this is the lowest level of knowledge continuum. It's called pre-experimental or non-experimental when we're talking about research methodology, because these methods only explore the research question or the problem area. They don't provide description, they don't provide any correlation, any causation. They're just exploring that area. Generally, exploratory, which is the pre-experimental, the non-experimental, are going to fall more towards the qualitative side. However, the survey design, the one-shot case study, which is the survey design, is now classified as pre-experimental and non-experimental, and it goes into this exploratory level. The next level is descriptive, and this is the mid-level of knowledge, and this is referred to as quasi-experimental designs. And they're quasi-experimental because they resemble an ideal experiment, but they lack at least one of the necessary requirements to be an ideal experiment, if not multiple areas of that. So we go from exploratory, which are pre-experimental or non-experimental, to descriptive, which are quasi-experimental. They actually have a few more levels of rigor in the design for them to be able to provide more substantial or credible knowledge about the problem area, but they're not at the explanatory level. And when we get to the explanatory level, this is the highest level of knowledge, and these designs have the most requirements that must be met. You cannot make statements about cause and effect. Variable A caused variable B or caused the change in variable B. You cannot make those statements unless you develop the highest level of research knowledge methodology, which would be at the explanatory level. These are the only ones that can seek to establish that causal relationship. Now, it doesn't mean we don't step back to exploratory and descriptive and try to make them causal, But in the scientific world, we cannot make those statements about any treatment, intervention, and outcome unless we have conducted an explanatory level research method to gather that data and make that decision. There are essentially two overarching group research designs, and it's a one group research design and it's a two group research design, or it could be more group research design beyond the two. But generally these are the two group research designs we look at. And again, the main difference in the two classification is that one group designs don't compare their research participants with another group. If you have a two group design, you can actually be comparing them with another group, or you could be comparing them. Two group comparison, we're actually comparing groups on the dependent variable. And let's step back and remember what an independent variable and a dependent variable is. The independent variable is the variable that we are looking at as impacting a change in the dependent variable. The dependent variable is what we're looking to change. And when we're talking about group research designs and interventions and treatments, your treatment or your intervention is always your independent variable, and what factor you're trying to affect in the client or clients is the dependent variable. So if you have intervention A, B, and C, and you're using this intervention to reduce the levels of depression in your client group, then you can actually say levels of depression in my client group are dependent upon the intervention ABC. Intervention ABC becomes your independent variable, and levels of depression is your dependent variable. You always have to figure that out because the dependent variable is what we're wanting to impact. The intervention is the independent variable, and it's the one that we're wanting to be able to say makes a difference in our dependent variable. So this is where we look at comparing the groups on that dependent variable to determine if the intervention or had any impact on that dependent variable. Obviously, the simplest of group research design is going to be the one research group. You're just going to have one group. And in that one group, you may do a one group post-test only. You can do, again, that cross-sectional survey design where we actually implement a survey of a group of individuals. This is now considered a group research design. We also have longitudinal designs where we look at trend studies, cohort studies, and panel studies. But these are essentially the same groups of individuals over time, so it's not a comparison. And then we can have a one group pre-test, post-test design where we actually give one group a pre-test, an intervention, and then a post-test. So these are some of the examples of one research group where you can actually look at how the dependent variable is being impacted by the independent variable without a group comparison. The next level of research designs are two group research models. And what I have here in this slide over here that are highlighted is representations of what that might look like if you see that in a published article. The X's mean the intervention, O's mean the observation. So when you look at the first one, post-test only with non-equivalent groups, so that means I'm going to have two groups. I'm going to provide an intervention to one group, and I'm going to measure both of them at a post-test. So an example of this would be is you guys are my research group, and I'm going to compare you with Dr. May's family's class, the students that are in there, on research knowledge. So you're non-equivalent groups, and I'm going to, at the end of the semester, after I provide in research instruction, I'm going to give you a post-test, I'm going to give them a post-test, and see who has more research knowledge. Really can't tell me a whole lot other than a snapshot in time to say who has the most research knowledge at that point in time when you took that post-test. It can't tell me what your knowledge was before, if there was a change in knowledge, if my instruction worked. It can't tell me anything like that. It can only tell me if there's a difference in knowledge between the two groups. If I do a pre-test, post-test with a comparison group, then maybe I'm going to, okay, let's say pre-test, post-test comparison group. So what this would look like is there would be a pre-test given to both groups. Only one group would receive the intervention, and there would be a post-test given to both groups. So this actually allows us to make a little bit more conversation about the outcomes of the dependent variable, which would in this case be the knowledge measured by the post-test and the pre-test. We know where we can compare the groups on where they were at the knowledge continuum on the pre-test, and we can compare them on the post-test. And because one group got the intervention, which whatever that was, instruction or whatever, then we could actually say that that was one variable, the intervention, that this group had that the other group didn't have that may have impacted that outcome. So it gives us a little bit more credibility again to those findings to be able to say that our intervention impacted that dependent variable. We can also do multiple time series designs, and it's the same thing. You have observation 1, 2, and 3. You have an intervention. You have observation 4, 5, and 6, and you do it with comparison groups, or you can do it with non-equivalent groups also. These tell you, each one of these tell you a little bit more about the impact the intervention had on the dependent variable. And that's what we're wanting to do, is we're wanting to move up that level of methodology so that we can have very rigorous methodologies, studies, and be able to say with strong credibility that these interventions impact this problem and there will be an improvement if A, B, C happens. So that gets us to the highest level of research designs, and these are the explanatory. The explanatory research designs are the most rigorous, and they must meet all the requirements before the findings can be ruled causal. And this is very important, and for research, social work research, many times we don't get to this level of research design, and because there's some ethical considerations in here, there's the fact that we most often are dealing with our clients who are our participants, which actually prevents some of these factors for being able to be implemented. This explanatory level really represents what it would look like to conduct research in a laboratory setting and not necessarily in a human subjects setting in the real world. But it's important to understand these so that you can be a good consumer of research. And in some of the articles that are published, the authors actually may extend their conclusions and their findings beyond what their methodology would support, and you would be aware of that, because then you would know that they don't have these characteristics in their study, and therefore the statements they're making can't be credible. So that's one area of being the consumer of research that's important. In order for us to truly make causal statements that variable A caused the change in variable B, we have to include all of these components in our research study. We're going to talk about the time order of the independent variable, how it's manipulated, relationship between independent, dependent, the controlling for rival hypothesis, the control group, and random assignment procedures. So first off, the time order of the independent variable must be established. The independent variable must precede the dependent variable. This is crucial if our study is to show that one variable causes another variable, because something can't occur later and cause something that occurred earlier. So let's use the example again of depression. Our independent variable, which is our treatment for depression, must precede a decrease in the levels of depression in our clients. So if our client's depression level is dropping and we provide the intervention even though it's dropping, we cannot say it was our intervention that resulted in the drop. The level of depression was already dropping when the clients came into our intervention. So the independent variable must precede the dependent variable. And that's just one example. This gets a little tricky and you have to really kind of think about it sometimes, but that treatment, that intervention, whatever that independent variable is, has to be present before the dependent variable or the changes in those dependent variables occur. Otherwise, you cannot say that there's a causal effect there. The independent variable has to be manipulated. So that means we actually have to do something with the independent variable. And this could actually be just making the independent variable become present. It could actually just be introducing the treatment versus the independent variable being absent, no treatment. It could be manipulating it in terms of the magnitude of the treatment or the intensity of the treatment, whatever that could look like. But we have to do something with the independent variable. It has to be introduced. It has to be manipulated in terms of intensity or in terms of magnitude, something like that. So there has to be some change in that independent variable for us to be able to make that statement about causation. There has to be an established relationship between the independent and dependent variable. Initially, this relationship is established through the theoretical perspective, the literature review that you do, the knowledge level that you have. You understand that there's going to be a relationship between the independent and the dependent variable. We know that there's a relationship with introducing cognitive behavioral therapy and decrease in negative thoughts, because we've read that, the theory is out there. The next step that we have to do, though, when we're looking at the relationship between the independent and dependent variable would actually take place after we've gathered our data. We can do statistical analysis to determine if these are correlated. And what we want to see is that they move together. So whatever we're trying to impact, if the independent variable increases, then we want the dependent variable to increase or decrease. We want those to move together. That shows that there's a relationship. If there is no relationship between the independent and the dependent variable, there's no need to evaluate further, because it doesn't make any difference what kind of statistical analysis you do, what kind of interpretations you do. If they're not related, they're not related. We could actually say that in August, the sale of guns increases in Texas and the sale of ice cream increases in Texas. We could try to say that it's because of the hot weather that impacts both of those, but those are not going to be related in any way. There's no relationship between hot weather and the sale of guns. There may be a relationship between hot weather and the sale of ice cream, so that could be that we could establish a relationship there, but maybe the other one we can't. We actually have to have a theoretical perspective to say that those two variables are going to be related, and then we will eventually do a statistical analysis to show that in our sample population they actually were related. And the one thing that we're really trying to do when we look at this explanatory level of research designs is we really want to control for rival hypothesis. When you get to this level of explanatory research, you're actually going to be testing a hypothesis. Again, you have the theory that your two variables are related, so you're going to make a statement about that relationship, which will be your hypothesis. And what we need to do is we need to be able to eliminate any rival hypothesis that may be explaining the differences that we're seeing. So we need to eliminate any other explanation for the change in the dependent variable in our study. And we do this, again, at this explanatory level by setting up the best possible research design. And it depends on which group level of design that you're going to be choosing. But if you're doing explanatory, you're going to have a control group. And we'll talk about that in a little bit. Because if you don't have that, you're not going to be able to control for those rival hypotheses. Some of the methods that we do use for controlling this means holding variables constant, correlated variation, and analysis of covariance. Correlated variation, analysis of covariance are obviously statistical methods. Holding variables constant, there's some statistical analysis in that also, but we can also do that in terms of our sample population to try to hold some of those extraneous variables that would influence the outcome constant. And if a variable becomes constant, then it's no longer a variable. It doesn't change in any way, and therefore we hold it constant, and it no longer can explain any of the differences we see. I think the book gave a really good example of this, so I encourage you to read that. Read it a couple of times if you need to, so you can have an understanding of what that means to hold variables constant. You must have at least one control group when you're doing explanatory level research. And this is actually where it's going to become a little bit into the area of ethical conflicts for social workers. And our code of ethics say that we will not withhold interventions, we will not withhold services that are known to be effective, basically for purposes of research. We're not going to do that. So having a control group that may not receive the intervention is a problem for us in terms of practicing. It doesn't mean it doesn't happen, and it does. You'll see it in psychology, you'll see it in medical research. Again, those laboratory type settings, the control type settings, that this can be done. But for social work research, we really just don't embrace this aspect, because if we have an intervention and we have 50 people who need the intervention, we want to know if the intervention works. We're not going to randomly select 25 of those people and provide them the intervention and then observe 25 without the intervention just to see if there's a difference there. It's just something we don't do from a practice standpoint. But to have explanatory level research, you have to have at least one control group to be able to make those causal statements. And then when you have the groups, you're going to have a control group and you're going to have an experimental group, and there must be random assignment procedures employed when you're assigning the individuals to those groups, because this actually helps in terms of trying to ensure that the groups are equivalent in areas or variables that are important to the study. So random assignment is very important. And just like random sampling, random assignment, this is not a haphazard method. There are ways to randomly assign individuals to groups to meet that statistical level of qualification. So it's not a haphazard thing. And so we randomly assign the individuals to the groups, and then we can control for some of those rival hypotheses or those extraneous variables that would impact the study. So not only do you have to have a control group, but you have to have random assignment between the intervention and the control groups. All of these things that we have talked about in terms of that explanatory level of research, the random assignment, the requirement for the control group, the time factor where the independent variable comes before the dependent variable, controlling for those rival hypotheses, all of those characteristics are done in order to maximize internal validity. And internal validity refers to our ability to say that it was the intervention that resulted in the change of the dependent variable. If we can control the internal validity of our study and eliminate some of those outside explanations, then we're going to have a higher level of validity when we're actually making those statements. So internal validity refers to the approximate certainty about any inferences that we make regarding the cause and effect or that causal relationship of our independent and dependent variable. When we employ these factors in this explanatory level, those factors that we just went over that are required, it helps to promote higher levels of internal validity. So we have better control over alternative explanations, and with greater credibility can actually say the independent variable impacted the dependent variable. And ultimately, this is what we're going for in research. Ultimately, we want to know that this treatment approach is 100% effective with this behavioral concern or disease process or whatever it is when all of these factors are in place. That's what we're looking for. So we want high levels of internal validity. Again, internal, which means inside the actual research methodology, and the validity of what we have set up in that research methodology controls for any rival hypothesis. That's what we're wanting to do. So the internal validity is what we're trying to impact when we actually implement these group research designs under those highest level of standards. Some of the threats that we try to control for that impact internal validity include the history, maturation, testing effects. We're going to go over each of these. Depending on the group design that you select or are able to select and put into place, those requirements will impact each of these threats to the internal validity a little bit different. In other words, we cannot control everything 100%. There is no way where you're going to create the perfect research study and control everything 100%. So each of these factors can come into play, and depending on the group research design that you select, it may or may not control for one or more of these factors. So first of all, we have history. And history refers to any outside event, whether it be public or private, that can affect the program objective, and that wasn't taken into account in our design. One of the examples I like to use for this is in my practice, I'm treating individuals for anxiety. I have a 6-week course, and it's been shown, I have it established, it's been shown that from beginning to end, it will reduce anxiety levels by 50%. So let's say on week 4, 9/11 happens. That is a huge outside event that impacted all of our levels of anxiety. It's going to impact the clients in my group. And if I were to measure their anxiety as I did previously in previous groups, it may show, and it most likely will show, that trending down in anxiety levels is not happening. And that's because an external event happened that impacted their anxiety levels. And I didn't take that into account in my design because I had no idea it was going to happen. So it's something that I have to explain in my findings and in my conclusions. If I have a control group who's not getting the intervention, but I tested their anxiety at the beginning, and then I test their anxiety at the end, at the same time I test my group of anxiety, and their anxiety also went up, then I have a little bit more credibility to be able to say that it was that external event that happened because everybody experienced it, and it wasn't the lack of effectiveness of my intervention. So that's one way to think about history. Maturation is another one that impacts research, and this often is when we're doing longitudinal studies, and so we're actually gathering information at more than one point in time, or again, we're looking at intervention over a longer period of time. This refers to physical and psychological changes that just take place that are just natural. If you're working with children, if you're working with adolescents, then you're going to see more of the effects of maturation if you're trying to evaluate outcomes, and possibly in the elderly also. So these are things that affect the dependent variable or the program objective that are outside the control of your research study. It just happens naturally. Again, if you have some of these other things in place where you have a control group, you've had random assignment, so these characteristics of maturation are going to be pretty equal between the two groups, then it helps to control for some of this threat to internal validity. Testing effects can also be an issue that impact your internal validity, and this really has to do if you're doing a pre-test, post-test. If you're doing a pre-test, and especially if it's knowledge-based, it could actually impact your post-test scores instead of the intervention that you provided. Individuals could remember the questions. It's kind of like you take a test and then you go look up the questions and you look up the answers because you're like, oh my gosh, did I get that right? Well, that can happen too if you're doing pre-test, post-test in some type of a research study. So testing effects too can impact that. You have to consider the length of time between the pre-test and the post-test and what's going to be the optimum length of time so that you can reduce the testing effects if at all possible. Instrumentation error can also happen. You could have the most perfectly designed explanatory group research study methodology, and you could introduce instruments that don't have reliability or validity established with the population you're working with. So under those circumstances, you're going to have instrumentation error that's going to impact the validity, the credibility of your findings. Also too, how it was made, where, when, how, by whom it was made. If you change instruments along the way, that's going to be an instrumentation error. You can't really do that. Again, mechanical breakdowns, and I think the book used the example of the EKG. It was a mechanical breakdown, but we can get that with technology because so much of what we do now is done through technology. So we have to take that into account too. So if any of these factors happen during your research study, then it's going to lower your internal validity within that research study. It's going to lower the level of confidence that you have in your results. Statistical regression, and this refers to the tendency of extremely low and high scores that are going to regress towards the average score for everyone in the study. This is just, again, a natural phenomenon that happens. So if you're actually implementing some type of instrumentation that is a scale that's measuring somebody on a number, and you do it multiple times, there's just a natural tendency for all of us to move towards that average, the mean for the group. This is a natural phenomenon that happens. So depending upon your research methodology, this could actually be a threat to your internal validity. Differential selection of research participants, and this refers to any lack of equivalency among the formed groups of research participants. And what this means is you want to use the random assignment to try to get that equivalency in those variables between the two groups. If you don't have the random assignment, true random assignment, and even in some cases where you're able to do that, you could actually get a lack of equivalency. You could end up with one group that has more of the variable attributes you're measuring than the other group. If you follow the methodology for the explanatory level, this should actually be a lower risk, but it's still a risk in your research study. And then when you get your data and you analyze those characteristics of your sample population, you can look to see if your groups were equivalent or not. And if they weren't, even if you did random assignment, then you're going to have to account for that. That then is going to become a limitation of your study. Mortality is just the fact that if you're actually doing something over a period of time, research participants are going to drop out. They just naturally do. This can have an impact on your findings because those who drop out may have specific characteristics that resulted in them dropping out that would also explain some aspect of your study. Mortality is important. Mortality also happens in medical research, and that is specifically because they may be looking at individuals who have terminal conditions and may actually die during the research. There's a set of statistical procedures called event history analysis that if you're conducting a study that may end up with mortality and you know that it's going to end up with mortality, you can employ that statistical analysis because it helps to account for that. But for the basic aspects of research that we engage in, we don't concern ourselves with doing event history statistical analysis, but we do have to take into account if we have participants who drop out over the course of our data collection. Reactive effects of research participants. We are human. Studying human behavior introduces a whole lot of variables that we can't control, and this is one of them. And just the changes in our behaviors or our feelings alone can be caused by participating in the research study or the knowledge that they're participating in the research study. So sometimes you'll see in the research they'll report blind research studies, the placebo effect in medical research where the participant doesn't know if they're receiving the treatment or not. Again, this goes against ethical standards for social work practice because we uphold the fact that participants, whether they're engaging just in intervention or they're engaging in research, have the right to informed consent. And so they have to have all the aspects of what the study entails and give their consent to participate. It's something that we hold very dear in terms of our practice and our research level. So thus, we may never make it to the full explanatory level of research because we're not going to compromise that ethical standard just for the purposes of not having reactive effects of participants. Interaction effects, and this actually refers to if there's a combination of two or more threats to the internal validity. Anytime that there's two or more things that happening, history and maturation, instrumentation error, statistical regression, or whatever that may be, it's a compound effect, and these interaction effects can then provide threats to internal validity. And relationships between the experimental and the control groups. Again, we're humans. We're going to talk depending upon how the setting and how it's set up and the groups are designed and the methodology is designed. These individuals actually may interact with each other. So say you do have an experimental group and you do have a control group, and the experimental group is actually receiving the treatment and the control group is not. You can actually get some compensatory rivalry, some demoralization, There's going to be conversations that are happening. There can be some diffusion in the treatments. So this is a very human aspect that, of course, we can't always control. So we actually want to try to minimize it as much as possible, but then we also have to recognize it if it does happen. And again, it will be a limitation to the study. Then finally, we're going to take just a brief look at external validity. And this refers to if the results of our specific study can then be generalized to another population, another setting, or another time. So we have our sample participants. We have met all the requirements in terms of the sampling procedure, random assignment, control group, all of that. We can, with some credibility, say that if the independent variable made the change in the dependent variable in this group that was within our study, it will also do the same thing in another population or in another setting or at another time. It takes a very high level, sound methodological procedure to actually be able to meet the research, the level of external validity. And again, this is something that we do commonly in practice because we read one research study. It could be exploratory, descriptive, quasi-experimental, and we just take the results of that one study and then all of a sudden we apply it to the whole population or we apply it to the whole community or something like that. Unless we actually have that high level of explanatory research, external validity doesn't happen. And then the main threats to this include selection-treatment interaction, specificity of variables, multiple treatment interference, and the research bias. If you employ those steps that we talked about in the explanatory level of research, you're going to control for a lot of these, and you're going to be able to, with more confidence, say that your findings can now be applied to somebody else, even though they didn't undergo the research. In social work, because we never get to that level, what we find, we just can't, it has no external validity. It only talks about the individuals who actually participated in our study. Again, medical research, psychology, some of the harder sciences will have external validity. But those of us who deal with the human behavior aspects of it, we just don't have the external validity to be able to say that what we read in this article can now be applied to every population. We do that all the time, and that's a fallacy. It's an ecological fallacy in research that the data is having more credibility than it really does in terms of that.